ladies and gentlemen. We are continuing our discussion on lipids, but primarily phospholipids in this episode. And so, in the episode prior, we did discuss phospholipids, the chemical formula, what it looks like, what it's formed from. Now we're going to continue that discussion. So we left off, remember, with this image. So you got the glycerol, one fatty acid, two fatty acid, and the phosphate group. So this phosphate group, so all lipids are all or mostly nonpolar, and that's where the mostly nonpolar comes into play with phospholipids, especially here. So the phosphate group of this big phospholipid molecule is polar, but the entire phospholipid, due to the majority of it being nonpolar due to the fatty acid chains, the phospholipid is mostly nonpolar. So there is a term for this, as there's a term with freaking everything in anatomy, and this term is phospholipid molecule is amphipathic. That's AMPHIA, so not amphitheater, amphipathic. And amphipathic means a molecule that has both polar and nonpolar regions. So phospholipids are amphipathic, meaning they have that small polar region and then a nonpolar region as well. So amphipathic, as long as it has polar and nonpolar regions, that is the definition of whatever molecule we're speaking of. But phospholipids, some polar, mostly nonpolar, but it is an amphipathic molecule. And analogy for amphipathic, it's kind of far out, but think of whatever, I'm not sure what times it's from, whether the Greek, the Mayans, I couldn't tell you, to be honest, but a minotaur. So a minotaur is a head of a bull and a body of a human. This mythology, so it has the head of a bull, body of a human. Think of the head as being polar, and then the body, the bull part, or the human part, I guess, as being non-polar. So head of a bull, body of a human, that polar part, non-polar part, a minotaur is, in our analogy, amphipathic there. So in our case with the phospholipid molecule, the polar head is the phosphate group, and then the nonpolar tails are the fatty acid chains here. So I'm gonna flip the switch. Look, I just flipped the switch. I'm a Drake. I'm a knockoff version of Drake. But here's the polar head, and then the nonpolar fatty acid tails. So this is just to give a visual representation of what all this looks like. So polar head, nonpolar tail. We actually call this polar head hydrophilic, and the nonpolar tail hydrophobic. So think of it like this. Hydrophobic is being scared of water. So nonpolar molecules are they repel water. They're insoluble to water, so they don't dissolve in water. But hydrophobic, think of obviously phobic. Break down the word. So hydro means water, phobic means phobia, kind of scared of something. So think of arachnophobia or whatever, when people are scared of spiders. So arachna is the spider, phobia is the scared of, hydro is water, phobic, the phobia is the scared of. So hydrophobia, hydrophobic altogether is scared of water. So nonpolar fatty acid chains, fatty acid tails repel water. On the other hand, hydrophilic is the opposite. So hydrophilic, you got that hydro. I don't know what the hell philic means, but it's the opposite of phobic. Philic, so hydrophilic, water attracting. So attracting water, so it's the opposite, essentially, of hydrophobic. So hydrophobic, scared of water. Water, get away from me. Hydrophilic is attracting water. So hydrophobic, scared of water. Hydrophilic, come here, water. Come here, baby. And that really wraps up our discussion here on phospholipids. But just a reminder, amphipathic is polar and nonpolar regions. Phospholipids are amphipathic due to that phosphate head, that polar head, that hydrophilic head. And their nonpolar regions are the hydrophobic, the fatty acid chain tails. So that's what makes, say, triglyceride completely nonpolar. It has all the fatty acid chains, no polar regions, where attached to a glycerol and a phospholipid is two fatty acid chains. That's the majority of the nonpolar region. And then it has that sneaky little phosphate group in there, which is polar. It makes that polar head, making phospholipid molecules amphipathic. Boom, we got it. amphipathic, polar, non-polar, hydrophobic. I'm scared of water, hydrophilic. I'm loving water, and that's that. And we're gonna continue our discussion on lipids here, talking about steroids. I'm gonna bring in Mark McGuire for this one.